Hello everyone, this is my homework 2, number 2 with the topic of servo motor. Uh, this homework is from Arduino book example 3.10, displaying servo motor angles on LCD with Arduino. This is the hardware that I use: one Arduino Uno, one micro servo SG90, and one LCD 16x2 and I2C to LCD module. This is the software. I use Arduino IDE version 2.3.4 and with the dependencies of Servo.h by Michael Margulis and Arduino version 1.2.2 and Liquid Crystal LCD by Frank de Bender version 1.1.2. Okay, before I continue, I will explain about the servo motor. I will explain about servo motor. Servo motor or servo refers to any closed-loop control system that operates using negative feedback. An example of a servo system is the cruise control in a car, which monitors the vehicle's speed and uses that feedback in a control circuit to adjust the accelerator, ensuring a consistent speed. In the case of RC servo, the output shaft position is continuously measured and fed back to an internal control circuit. The circuit adjusts the motor's current to maintain the desired position. This is some servo motor example. The price is from $9, $11, $12 like that, up to $42 or $43. The what is it? The type or the mark? Can be high tech like that. And also this one is high tech. All of it is high tech. This one is parallax. And the price ranging also from $40 like that. We have some what is it? Some example for servos, the types, the color, something like that. And what is a closed loop in the servo motor? Servo motor are sophisticated device that control their movement with pinpoint accuracy. So it means that the accuracy is so good. They work on the principle of a closed loop system, meaning they constantly monitor their position and adjust accordingly. As you can see, this is the industrial servo motor with this one encoder, and this is the generic servo motor. And the sensor we have here is potentiometer. So the position sensor in here can be encoded for industrial motor or potentiometer in the generic or hobby servo motors. As like this, as I mentioned before, uh, for the industrial yeah, we utilize high precision encoders to track position, and for RC car, something like that, we employ only potentiometer. And the control loop is the motor actual position is measured by the sensor. This information is compared to the desired position, and any difference or error is detected. The motor is then adjusted by the controller to minimize this error and achieve the target position. This is inside the servo motor. There is a gearbox like this with high torque, but the what is it? The RPM is so slow, and there is a potentiometer to serve as a what is it? Position sensor. This is the central control circuit, and this is the DC motor with high speed and low torque. Okay, this is the real breakdown of servo motor. This is the as we usually use DC motor. This is the position potentiometer, and this is the circuitry with a small microcontroller or a specialized servo IC. This is the gearbox, and this is the color scheme. As I said before, this is we can see that the color is mostly black, red, yellow, but this one is different: black, red, white, maybe. Okay, so this is the color scheme. This is the table below provide a summary of common color scheme encountered in electronics. This is for a mnemonic easy to remember. This color code associated darkest color, usually black or brown, is usually connected to ground, and while red is usually connected to power. Okay, this is Futaba. If Futaba, we can black, red, white. If from GR, brown, red, orange. If high tech, we can have either black for ground, and for power we can red or brown, and control signal we can see yellow or white. And for the we can see that what we need to consider, and if we want to connect to servo motor, we need to always refer to the datasheet. Achtung, achtung. Okay, there are two types of servo rotation. The standard rotation, we can see that it almost it more than 180 degrees, but it's not more than 270 degrees. And this is the first type, and the other type is continuous rotation. It can move continuously like that, and we can still have the desired position. And a little bit theory about PWM, or pulse width modulation. PWM is a cool term to represent a type of digital signal. PWM can be generated using a simple IC like an E555. It can also produce from a microcontroller output, Arduino development board, for example, or using AFG function generator. Dati cycle states that the ratio between on time and the total period on time and off time. That's dati cycle. So for this example, this one is 25% dati cycle. This one, because the high logic and the off one, this is the on time, this is the off time is same. So this is 50% dati cycle. Dati cycle is usually expressed in the percentage. And for the servo motor, we can see in here, if the on time is only 1 millisecond or 0.5 millisecond, the servo will move to 0 degrees. Okay, this is 20 millisecond or 50 hertz. And if we want to move the servo motor to the 90 degrees, the on time should be set into 5.5 millisecond with the same period of time, 20 millisecond. If we want to move the servo to 180 degrees, we should set the on time to 2 millisecond or 2.5 millisecond. According to the datasheet, we should refer to the datasheet. So this is a little bit theory about the servo motor. And because we will use the Arduino, not all pin of Arduino can be connected to servo to control the servo motor. So it should be in some of these pins. The pins that has infinity symbol like this one, pin 3, 5, 6, 9, 10, 11. Okay, that's from a little bit introduction about servo motor. Thank you so much. After servo motor presentation before, I want to explain about the experiment that already I've done. So this is the wiring diagram. I will show you in the this is the minimum system of Arduino. It has crystal and so on. This is the reset button. This is the LED that connected to Arduino pin 13. As you can see, this is the LCD 16 by 2, and this is the I2C using this is the I2C to LCD. So it has to connect to SCL and SDA, Arduino, or pin A4 or A5 and A5. And this is the servo motor. I connect the servo motor to pin 11. So this is the code that I already download to the Arduino. This is the angle 0, angle 1 is 0, defined as 0, angle 2 is defined as 90, angle 3 defined as 180. I use these two libraries, and this is I use the servo to attach it in the pin 11 as this one. So this is the control for the loop, servo right angle, blah blah blah. This one is for servo right angle, blah blah blah. We have a delay of 3 seconds for each angles, and it will print to the LCD. I might have to show you the video. Sorry, this is the video. This is the servo motor, and this is the jumper. This is the LCD connected to A4 and A5, and for this servo motor is the orange connected to pin 11. This is the angle 3, this is the angle 1, 0, and it will move to angle 90, and as you can see angle 3, angle 290, angle 3 is 100. Okay, thank you so much for the presentation that you've heard. So see you in the next video. Thank you.